Welcome to the fastest way to learn data structures and algorithms with this premium revision material.
Today we are mastering LeetCode 209. Minimum Size Subarray Sum. This is a classic sliding window problem, a favorite for interviewers at Google, Meta, and Netflix. Let us look at the problem statement. We are given an array of positive integers and a target value. Our goal is to find the smallest contiguous subarray whose sum is greater than or equal to the target. If no such subarray exists, we return 0. Think of it like an expanding and shrinking accordion.
You stretch the accordion to reach a certain volume or target sum. Once you hit that target, you try to shrink it as much as possible from the other side while still maintaining that volume. We want the tightest squeeze possible. Our strategy is the sliding window technique. We use 2 pointers, left and right. We expand the window by moving the right pointer to add elements. Once the sum hits the target, we record the length and start shrinking the window from the left to find a smaller valid subarray. This ensures we check every possibility in just one pass. Now, let us dive into the dry run. Look at the screen. We have our array, and our target is 7. We start with both pointers at index 0. Our current sum is 0. First, we move the right pointer to index 0. The value is 2. Sum is now 2, still less than 7. So we move right to index 1. The value is 3. Sum becomes 5, still not there. Next, we move right to index 2. The value is 1. Sum is 6. One more. We move right to index 3. The value is 2. Sum is now 8. 8 is greater than or equal to 7. We found a valid subarray. Its length is 4. But can we make it smaller? Let's shrink from the left. We move the left pointer to index 1, subtracting the value 2. Sum becomes 6. 6 is less than 7, so the window is no longer valid. We continue expanding, moving right to index 4. The value is 4. Sum becomes 10. Now we shrink again. Move left to index 2, sum is 7. Still valid. Length is 3. Move left to index 3, sum is 6. Invalid. Finally, we move right to the last index. The value is 3. Sum becomes 9. Shrink left to index 4, sum is 7. Valid. Length is 2. Shrink left once more, sum is 3. Invalid. We've reached the end. The minimum length found was 2. Now let us look at the Python implementation. We start by initializing our left pointer, our running total sum, and our answer variable to infinity. As we iterate with the right pointer, we add each element to our total. Then, while our sum is greater than or equal to the target, we update our minimum length and shrink the window from the left by subtracting the value and incrementing the left pointer. Finally, we return our result, or 0 if no such subarray was found. Looking at the complexity, the time complexity is O of n, because each pointer moves at most n times. The space complexity? O of 1, we only use a few variables regardless of the input size. And that is the minimum size subarray sum challenge mastered. Save this video for your next technical interview, and follow Leo Academy for more 10x premium DSA guides.